So let's say we have this equation, y equals x squared minus 3x, and we're given that x equals 3, and when x equals 3, dx over dt equals 2. And we're trying to find dy over dt and what that is. And basically we're assuming that we're differentiating this equation with respect to time. And here's how you solve this. So first you just differentiate this. Dy over dt is equal to 2x times dx over dt minus 3 dx over dt. And then you plug in everything you know to find dy over dt when you're given these two. So dy over dt is equal to 2 times 3 times 2 minus 3 times 2, which is equal to 6. And whatever units they have, but in this case, you're not given any units, so you just write 6. And that's how you solve related rates problems. So that example is kind of easy, so let's try one that requires deeper thinking. Let's say we have a ladder that's 25 feet tall, that's leaning against the wall, and it's sliding down the wall, which means that the tip of the ladder is sliding down like this, and the bottom of the ladder is sliding away from the wall to the right, like that. And we're given that the distance between the bottom of the wall and the tip of the ladder is 7 feet, and the tip of the ladder is sliding down at 3 feet per minute. And we're trying to find how fast the bottom of the ladder is moving away from the wall to the right. So if you haven't noticed, we've kind of created a triangle here, and with the wall, the floor, and the ladder. And let's label our variables, x and y being the distance between the bottom of the wall with the ladder. And we've created a triangle here, so we can rewrite this as x squared plus y squared is equal to 25 squared. Now the reason we don't set the length of the ladder to a variable like x or y is because it's always constant in this case, while x and y are changing in this scenario. And let's differentiate this. So 2x dx over dt is equal to, plus 2y dy over dt is equal to 0. And if you think about it, we're trying to find dx over dt because that's the rate at which x is changing with respect to time, or how fast this ladder is moving away. So we already have y, which is 7 feet, and dy over dt, which is 3 feet per minute because the tip of the ladder is moving down, or dy over dt would be -3 actually because y is decreasing. All we need to find is x, and we can use our Pythagorean formula. So x squared plus y squared is equal to 25 squared, and plug in 7 for y, we get x squared plus 7 squared equals 25 squared. And if you do all your math, you get x squared plus 49 equals 625. You get x equals 24 feet. So now we have all our variables to plug in to find dx over dt. So we get 2 times 24 dx over dt plus 2 times 3 times 7 is equal to 0. 48 dx over dt, or this should be -3, sorry, is equal to 2 times 3 times 7, which is 6 times 7, which is 42. So dx over dt equals 42 over 48, which is 21 over 24, which is 7 over 8 feet per minute. And that's our answer. So just a quick review of the steps we did to solve this problem. First, we wrote an equation relating everything in this problem. This one is a triangle because you have a triangle with the wall, the floor, and the ladder. And then we differentiate it using implicit differentiation because we're trying to find the rate at which something is moving with respect to time. And we plug in the variables we knew, and we found something we didn't know, this x in this case, and then we plugged everything in back. We simplified it, and then we solved for the value we needed, and then we got our answer. So let's say we have this equation, a times b cubed is equal to 40. And we're given that when a equals 5, b is increasing at 1 unit per second. And we need to find what's happening to a at that moment. So first, let's use implicit differentiation to rewrite this equation as dA over dt b cubed plus 3b squared db over dt times a is equal to 0. And we're given a, and we're given db over dt. And we are not given the a over dt, or b cubed, or b squared, or just b. And to find b, we can plug in a into the original equation. So when a equals 5, it's 5 times b cubed is equal to 40. And we get b cubed is equal to 8, which means b is equal to 2. So we found b, and we have db over dt because b is increasing at 1 unit per second, and we have a. So now we can rewrite everything as dA over dt, and this dA over dt is what's going to be our final answer, what's happening to a. Whatever we get for this, let's say our answer is 1, and that means a is increasing at 1 unit per second at that moment. So first, let's just plug in everything we have. So 2 cubed plus 3 times 2 squared times 1 times 5 equals 0. And we get dA over dt is times 8 plus 3 times 4 times 5 is equal to 60 equals 0. And we get dA over dt is equal to negative 7.5 and units per second. And that's our final answer. So what's happening to a at that exact moment when a equals 5 is that a is decreasing at a rate of negative 7.5 units per second. So let's say we have this circle with diameter AB and the radius is 5 centimeters. And we have a point P on the circle that's moving clockwise and such that it completes 1 revolution in 10 seconds, which means that it's moving around the circumference of the circle, and after 10 seconds, it's going to end up exactly where it started, and it's going to continue forever. We need to find the rate of change of AP when P is exactly at point B, at this point, directly across from A. And this might be kind of hard to visualize an answer to because it's just a straight line, but if you think about it, at any other point on the circumference of the circle, let's say P is right here, it forms a triangle with A and O. And we already know that AO is the radius, which is 5 centimeters, and OP is also the radius, which is 5 centimeters. And let's label this side AP as M and this angle as theta. So now we have a triangle, and let's use the law of cosines to write an equation. So m squared equals 5 squared plus 5 squared. And the reason why we don't use variables for these two 5s is because they're constants. Whenever p is moving, the radius does not change, and both of these 5s are the radius, so we just keep it as a constant. Plus 2 times 5 times 5 cosine of theta, and theta and m are both changing, that's why we leave it as variables. So now let's differentiate this. 2m dm over dt equals 50 times negative sine theta times d theta over dt. And now we have dm over dt, which is what we're trying to find, as it's AP, and we're trying to find the rate of change of that. We have m, which is, because p is directly across from A, it's the diameter, which is 10 centimeters. So m is 10. And then we need to find theta and d theta over dt. So theta is also pretty easy. Since it's a straight line from A to B, it's just a straight line, so the angle is 180 degrees, or pi radians. So theta equal to pi, and d theta over dt. This is also pretty easy. Since p is moving at a constant rate, we can say d theta over dt is just the change in theta for 1 full revolution, that is 2 pi, over the change in time, and 1 full revolution takes 10 seconds, so d theta over dt is pi over 5. And now we have everything, and let's plug it back in. So 2 times 10 dm over dt is equal to negative 50 sine pi times pi over 5. And we get 20 dm over dt is equal to negative 50 times 0 times pi over 5, which means this right side is all 0, and that dm over dt, or the rate of change of AP, has to be 0 units or centimeters per second. And that's our final answer. So everything that I explained and all the problems that I went through should give you a good introduction to solving problems involving related rates. If you learned something from this video, or if you enjoyed it, then please consider liking and subscribing.